Next part is, again, solving for the surface area of a pyramid. We're going to start taking a look at rectangular pyramids. So a couple things to remember here. When solving for the surface area, two different areas are needed. The base, okay, so remember that the base area is needed. Okay, so that's going to be the bottom or the top if it's inverted. And the lateral area is needed as well. So we need to find the base and the lateral area and then combine the two of them to make a full pyramid. We can also think of finding every side and then adding it all together. That would work as well. Okay, that would be one way of solving for a pyramid as well. We have the base, and we have all the triangles around the outside. Now, a rectangular-based pyramid, okay, is a little bit different from a square-based one or a regular-shaped one, whereas the square-based pyramid has two different and unique slant heights. It's a little difficult to show this to you in a video. It'd be nice to have like actual physical models in front. We could actually see that they are different by measuring them out. But in the video, it's gonna be a bit tough. What I'm gonna do is I'm gonna draw out the net of this pyramid. This is a rectangular based pyramid, and we can definitely tell that it's rectangular because the length, and we're gonna put an L there, I know it looks a little like a 1, and the width are definitely different, okay? And we're gonna understand that it is definitely different on this rectangular based pyramid. Now, to draw out a net of this pyramid here, and I'm gonna actually use black. I don't often use black for my drawings, but use black. What we're gonna do is we're gonna have this rectangle. That's gonna be our base, length times width. Then we're gonna have a couple of triangles. I'm gonna have to draw this out a little differently here than I was planning to. That's okay. All right, so here's one triangle. It's gonna be on this side. See if we can make, I guess they don't have to be completely equal. There we go, that's close enough. And then we're gonna do another one on the bottom, which is gonna be the exact same size as the one on top. This is definitely a little more difficult to do this on the computer than to do it. There you go, pretty close to the same. We're gonna call it the same. We are then gonna draw out two more triangles to go on the sides. And one on this side, might as well draw them right away. And then with our selecting tool, let's see here if we can, this will just take a moment here. All right, so here's gonna be one of our triangles right there, and our other one is gonna look like this here. All right, the joys of using technology. Roughly like that. Okay, so this is now our triangle or our rectangular based pyramid. As I mentioned here, this is going to be our length right there. And on this side, right over here, we're going to have our width. See if we can get in there. All right, we have our length and we have our width. Now, in this pyramid, you'll notice that we have two different triangles. And in fact, the sides of the triangles are going to be the same, but the height of the triangles are going to be different. So we're going to actually have two different heights. We're going to have this slant height right here, which is going to be associated with the length. And we're going to have this side length slant height here, which is going to be associated with the width. Okay? And I like to, what I'll often do is I'll try to call them slant height 1. And so let's put in here slant height 1. And this one is going to be slant height 2. Okay, slant height 1, slant height 2. Slant height 1 is dealing with the length here, slant height 2 is dealing with the width. So to find the area, we got to find the rectangle, this area, and we can multiply those two triangles by 2 because these opposite triangles are going to be the exact same. So let's do an example of a rectangular based pyramid. Okay, you'll notice here that this pyramid right here is dealing with, is a rectangle. Okay, it's 2.8 by 2.5. Looks very much like a square, but it is in fact a rectangle. So to find the surface area of this, what we're going to have to do is going to be the base area plus the one lateral side plus other lateral side. Okay, so that's how we're going to kind of deal with this here. I'm going to go in and put some other labels in. I'm going to call the base, we're going to be, it's going to be the base. And then here we're going to have triangle number 1. And here we're going to have triangle number 2. Okay, so we have triangle number 1 and triangle number 2. Number 1 is repeated on the back, number 2 is repeated on the left-hand side here. All right, so to find the areas, let's start with the base area. Okay, what we're going to do is our area is equal to length times width, so that's 2.8 inches times 2.5 inches, and this is going to equal 2.8 times is going to equal, really, wow, okay, 7 inches squared. That's going to be the base area. Okay, so that part is done. Next, we're going to find triangle number 1. And let's try to get it right there. Triangle number 1 area is equal to the triangle. So triangle number 1 has a base of 2.8 and a height of 4.3. It's going to be 2.8 inches times 4.3 inches. And then we are going to divide by 2 and then times 2. Okay, because there are 2 of them, right? So we're going to divide by 2 and then we're going to multiply by 2. Again, this is because it's a triangle. This is because there's 2 of them. Now, what you might realize is that you actually don't have to do the divide 2, multiply 2. You can just leave it because it's going to not change anything. And this is going to give us an area of 12.04 inches squared. So that's triangle 1 and its counterpart on the other side. Okay, and I'm just going to put that in as a quick this in here, 2 equal sides, and I'm going to draw a little line in there just to represent it there. That's why we multiply by 2. Okay, so I multiply by 2 because there's 2 equal sides. All right, triangle number 2. Again, we have 2 of them, so we're going to do the same thing, but now we have a 2.5 inch side. And we have a 4.5 inch slant height. Again, we're going to divide by 2, and then we're going to times 2. And again, we do that for the same reason, because we divide by 2 because it's a triangle. We multiply by 2 because there's 2 separate sides. We have our base and we have our slant height. Our area, 2.5 times 4.5, 11.25 inches squared. Let's get rid of that one there. That's now what we have is we have our base area. So that's the first part. Our first triangle, so one lateral side. Our second triangle, the other lateral side. And we're going to add them all together to create our total area. So we need to add them together to create our total area. So total surface area is, so we do this here, surface area is equal to 7 inches squared. There's our base. 12.04 inches squared, that is our first triangle. And 11.25 inches squared, that's our second triangle. And both of them. And so our total surface area will hopefully come up here shortly. Total surface area 7 plus 11 is 30.29 inches squared. And for whatever reason, it's not working right now to do the squared, but we should have a little squared on there. Let's see, maybe this will work now. Just a little bit glitchy here. No, it's not going to work. Okay, that's okay. Remember, this one right here was also because there were two sides. Okay, so that's also because there's two sides, and then we add them all together, and that is squared. I'm going to make sure to put that on there. I can even just write it on there. Okay, so that is rectangular based pyramids.